Let's run the model another time, and again we get false. Let's run it another time, and again it gives false. It means that in the 15 balls that we get out of the bucket, still we cannot have all the numbers. Makes sense because 15 is not a large sample size. Okay, let's make it a larger sample size. And since it is computer, we are gonna make it 90 without any concern about the difficulty. So now the V would be 90, a lot of things, and we want to make sure in 90 we have all these. It should be now success. Run it, and you see, my friends, now we have true. So it means that in all these 90 numbers that you see here, we have all the numbers from 1 to 10 at least one time. And let's run it another time. Again, true. Let's run it another time. Again, true. So it means that that's it. That's it. All those difficulties we had in understanding the problem and doing all the things, see how many lines, my friends. In R, you can do it. That's the point about R, and that's the reason I chose a difficult problem to impress you about R, and I wanted to give you enough motivation to learn R on yourself and become a brilliant expert that every employer wants to hire. Okay, let's continue our problem with another things. Assume that you want to know the exact probability. What is probability? Probability says that, for example, if you run a code 100 times, if 60 times is successful, it means that the chance of success is 60 over 100. Okay? Let me show you in a better way. Here is the last part for doing everything about the challenge. You agree that if you do an experiment 100 times and 60 times out of this 100 times is success, you will say the probability of success is 60%. So in another way, if you do something 100 times and 78 times it is success, you will say the probability of success is 78%. So here it says repeat the process for 1000 times, and after that calculate the number of success. N over 1000 is gonna be the answer. Why 1000? Because the results would be more accurate than 100. Okay, so now to calculate the probability of success if the sample size is 15, as we checked it in the R code, is we run it for 1000 times and we calculate how many success we have, and that's it. Okay, and again, my friends, it is just a review on a problem. I'm just showing you a demo about the power of R. You are not supposed to be good with doing this type of things on your own. You are just needed to be good with understanding of the things that we are discussing. Okay, before we do the code for counting the numbers, now I'm going to show you another power of R. Here you understand this, how we check if 1 to 10 is inside the V that we have. Maybe some of you on your own have done it this way, but again here I'm gonna show you the power of R. And instead of doing all the things we have talked about, this we can check this. Just check it. It says 1 to 10. Okay, 1 to 10 in V. What happens here, my friend? Here, it checks if all the numbers from 1 to 10 are in V. If yes, it is going to be true. Otherwise, it's going to be false. So just imagine, just see the power. If you have forgotten about this, you can check the video lecture we had last week. Okay, these two things gonna do the same thing. Here it checks one by one, but here it checks everything suddenly at once. So it checks if one is over there, if two is over there, three over there, and here again it does the same thing. 1 to 10 if it is inside V. Let's run this thing and check the results. So you see, it checks that it says all of them are true. So now we can use any of them, my friends. Okay, so here I make it this way. So now you can use any of these things, because from this we want to know if the experiment is failure or success. I can do it for you with any of these things. I don't know with which one I continue. I just wanted to show you it is this much strong way. And here I have put it. Here you can see also with if else you can put and the summation equal to 10. It means that all of them are available over there. And also you can use this one. Okay, so again it is a show off on the power of R over there. So let's continue with this and put the other part for you. Let's put the name of R here, and I put here if else. Still it can be easier. Okay, anytime I do anything, something better comes to my mind, and I like to do that like this. And again, the point is to showing you the power. It is not something that you need to learn one by one exactly. Just try to understand and get the impression. Okay, if else are equal to true, give me 1, otherwise give me 0. I'm going to remove this. Now it is recorded and you have the formula, and so you can use it later. So if else are equal to, that's okay, and I'm going to run it, and the sample size is 90. So now it gives me 1. So why I did this? Because I want to do the counting in a easier way. There are still other ways, but now I have 1 here, so I can use for the counting when I run it, for example, 1000 times. So start from here and put that as the summation, the number of success. You remember that in the previous slide that I showed you? I put it as 0. As 0, it creates it do the experiment. Okay, it do the experiment, and here it creates R, that if it is success or failure. And after that, it happens here, n equal to previous n plus this number. How many times we want this to happen? We want it 1000 times happen. So I put here for I in 1 to 1000 times. And you remember we talk about these structures, curly brackets, and we put it here. So it start with n equal to 0 and run it for 1000 times and calculate the number of success. And finally, here we have the calculation that we are looking for, n over 1000. And remember, we are doing a very difficult problem. Just see about the numbers of the lines that we have here. Okay, you know this reference curve that tells us about the probability. Let's go for some of them. We are going to use 30 and it should give us the probability of 62. Remember, my friends, with just 4 or 5 lines with R, you just have the same as this is a standard curve that even the expert in the field has problem regarding that. Don't get intimidated. Just get the impression of the power R can give you. Okay, we are going to use 30 and the answer is 62 something, and we are going to use also 50 that it should give us 95. Let's go over there. Ready for the magic? Let's go for that. Okay. Just before we start the running, I noticed the problem here. I missed 8. So I added in this way. So you see, before that it was checking if 7 is not over there and it jumped to 9. My bad, I missed that. So I added it here. And here we are gonna run it with 1000 times, and now everything is ready for that. So this change that you see, it was just a mistake. So here with sample size 20 we start, and with 30, I guess. Yeah, we were supposed to use it with 30, and the probability was 62 something. And remember, see my friend, the answer. See, R is providing you with just these lines that even these lines with if else could be written even easier. Let's go for another one with 50, that it was about 95 the probability, and as you can see, here is the result. So we can now create every other probability. Let's check the other points. For example, for 20 we have about 20%, and for 40 we have about 85, 86. So here I'm going to make it 20 and check the results. That was about 20. And see, it is the probability that it gives you. And the basic, as I mentioned, I'm very happy this video is recorded so you can check and double check many part of the story. But you run it 1000 times and you see how many times it has been success. And the other one, as the last one that we do, is 40, and it is the one 85 and 9, 86%, that is completely in alignment with the curve. And with all these numbers that you are getting, you can plot the curve in R as well. Please, my friends, be patient with this exercise. It was just a thorough example about the abilities of R, and you see now with the things that you learn in this class what type of complicated and confusing problem you can do. Don't take all these things for granted, and please practice, 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 and be patient with your learning process, because it's very important that you learn to think like a programmer. In the path, always feel free to reach out to me to ask your question. Thank you and good luck with your efforts.